Hi class, today we're going to be talking about the properties of real numbers. Let's start with our standardized test practice problem. What we're going to do is evaluate an expression. That expression is A times the difference of B and C quantity squared plus D. So what we do is we start with replacing the letters in the expression with the numbers associated with these. So I will have negative, negative 4, parenthesis, 3 minus 6 squared plus 5. And I want to make sure I use my order of operations. That being said, the first highest ordered operation is the parenthesis. So I want to simplify within the parenthesis. So I will have negative 4 times negative 3 squared plus 5. The next order of operations is the exponent. So I'm going to take negative 3 and square it. Negative 4 times 9 plus 5. Now I'm just left with multiplication and addition. So I want to do the multiplication first. I will have negative 36 plus 5. And I can simplify that to C, negative 31. Okay, we're going to talk about real numbers. And real numbers can be classified as either rational or irrational. The set of all rational numbers includes several subsets. That's what we're going to discuss now. These subsets include real numbers. We're going to represent those by an R. That is all rational and all irrational numbers. All we're dealing with are rational and irrational numbers. So a number, the first classification it will have will be an R because they are all real numbers. We're going to let Q stand for rational numbers. Rational numbers can be written as fractions, as in improper form. So you could have 2/3, you could have 3/2, you could write a whole number over 1, so let's say 7/1. Those are examples of rational numbers. I is going to represent irrational numbers. Irrational numbers can't be simplified into a fraction. So these would be numbers that have decimals that are non-terminating and non-repeating. An example of a decimal that would not be irrational would be 1.5 because it ends and there is no repetition. However, if you had a number that was like 1.57324, that would be irrational. We're going to let the letter Z stand for integers. Integers are just numbers that you see on the number line. They are the positives, 0, and the opposites. Whole numbers, represented by W, are the numbers on the right side of the number sign, or on the right side of the number line, and they include the number 0. Natural numbers, represented by N, are all your whole numbers except 0. Another word to use in place of natural, if it's easier, is to think of these as your numbers that you count with. So these are counting numbers. Okay, so these are the classification for rational numbers. We're going to use these letters to identify certain numbers. So we'll start with the two examples, and you can see that negative 11 over 3, if you simplify that, that just keeps going, and going, but it's repeating, and a rational number, or excuse me, an irrational number is non-repeating. So this is considered a rational number rather than irrational. The square root of 25 simplifies to 5. 5 is a real number. It is, we'll start from the back. It's real, it's rational, it's an integer, it's a whole number, and it's a natural number or a counting number. So if we try our examples, negative square root of 81 simplifies to negative 9. Negative 9 is real, it's rational, and it is an integer. The number 0 is real, it's rational, it's an integer, and it's a whole number. The number 73 is all of these plus it's also a natural number because we can count with 73. So we have R, Q, Z, W, and N. 34 1/2 can be rewritten as an improper fraction. 2 times 34 is 68 plus 1 is 69, so we can rewrite this as 69 over 2. Or if it was a decimal, it would be 34.5. So we know that it is real and it is rational. And then the square root of 42, I would recommend putting that in the calculator, and when you do so, you will realize that it is a non-terminating, non-repeating decimal. So this is our only example of an irrational number. It is real, but it is irrational. Now we're going to talk about real number properties. I'll list the property and then explain it. The first property is the commutative property. C-O-M-M-U-T-A-T-I-V-E. Commutative property. What the commutative property does is it moves things around. So this works with addition and multiplication. The order doesn't matter when you add or you multiply numbers. So commuting is going back and forth. That's one way to remember it. You're going one way, you're coming back the other way. So order doesn't matter. The second property is called the associative property. Associations are groups of things. That's the way I would say to help you remember this. So you can see that the order that things are in stays the same, but how we group them is different. That is the associative property. The third property is called the identity property. When we add a 0 to anything, we get what we started with. We get the identical thing. When we multiply by 1, we get the identical thing we started with. That is the identity property. The next property is the inverse property. And what this means in terms of addition is when you add a number and its opposite, you get 0. Or when you multiply a number and its reciprocal, you get 1. The next property is just called the closure property. The closure property just says that if you add 2 real numbers, you get a real number. If you multiply 2 real numbers, you get a real number. And the final property is one that I know you will all recognize. This is the distributive property. A is being multiplied by B, and then you're adding A times C. You might sometimes see that the term we're multiplying by is on the outside and the back. So you could go from inside the parenthesis and work outside. B times A plus C times A. So we're going to use these different properties with some expressions and identify what property is being used. So our first expression, 9x plus 3y plus 12y minus 0.9x, is being rewritten so that the x's are together and the y's are together. So we move things around. When we move things around and we're using addition, so we've got this little plus sign here for addition, we're using the commutative property. On the second line here, we're not changing the order, but notice we're grouping the 2 x's together and we're grouping the 2 y's together. This just helps making simplifying easier. So grouping things is the associative property. Then we're going to simplify. So because we've grouped these, we can just simplify 9 plus a negative 0.9, which is 8.1, and we're multiplying it by x, so that would be 8.1x plus, we're adding our 3 and our 12, that would be 15 times y, so 15y. Okay, on number 6 of our examples here, you can see that the order of everything is not changing. What is changing is how things are grouped. So when you change your groupings, you are doing the associative property. And this is the associative property of multiplication. So I'm going to put a dot there for times. Okay, now we're going to work with inverses, additive inverses and multiplicative inverses. The additive inverse is easy. All you do is change the sign. So negative 1.6, its additive inverse is 1.6. 8, on number 8, 5 and 5, 6 has an additive inverse of negative 5 and 5, 6. Now we get a little more complicated with the multiplicative inverses because we have to turn both of these into improper fractions. So to start with, if you have 1.6 over 1, you want to move your decimal out of that, so you move 1 to the right, meaning you add a 0 on the bottom. So we have 16 over 10. This needs to be reduced because both 16 and 10 are divisible by 2. So if we divide both of these by 2, we're going to have 8 fifths And now all we do is we flip it over and we say instead of negative 1.6 or instead of negative 8/5, our multiplicative inverse is negative 5/8. Let me circle that. So we keep the sign because when we multiply these together, we want it to equal 1. So the sign doesn't change with what we started with. We just flip our fraction. On the second one, 5 and 5/6, to convert to a improper fraction, we multiply the 6 and the 5 here, so that would be 30. Then we add the 5 in the numerator, that would be 35 over 6. Notice it's positive, so we'll keep it positive. Flip it over, we have 6 over 35. Okay, on our final two, we are just going to simplify each expression. There are some properties involved here. We're using the associative property to do a little grouping. And over here, we're going to use the distributive property. So we can start with what's in the parentheses. 4c plus 2c would give us 6c. And if we wanted to, we could go ahead and do 4c minus 2c, which would be 2c. Then we're going to bring down this minus sign, and we're going to simplify. That's going to leave us with negative 4c. And on the last one, we're going to multiply what's in the first parenthesis by 1/5. So if you think of 1/5 times 10a, that would be 10 over 5, or 10a over 5. That would give us 2a minus, if we do the same thing with the 1/5 and the 15b, 1 times 15b would be 15b over 5, which simplifies to 3b. Then we're going to put a plus, and we're going to do the same thing with the second parenthesis. So I'm multiplying 1 times 8b is 8b over 2 would be 4b. And 1 times 4a would be 4a over 2 would be plus 2a. Then we might use the commutative property to put the a's and the b's together. So we would have a 2a plus a 2a minus a 3b plus a 4b. Might make it easier to see that our final answer is 4a plus b. Now you've learned about the properties of real numbers. Hope you each have a wonderful day.